All right, so this is a bit of an experiment as I go. Bear with me. But what you've got here, I just kind of set the table so that we can save some time. But you've got 1, 2, 3, 4, 5 circles. I've arranged the second circle into a seed, and that's going to be my target circle. I've also cut this in half. I've bisected this vesica because I want that radius. Okay, I've determined that radius, and I'm going to lay that out across the circles that I've already cut. And not surprisingly, because it's half the radius of the other circles, they all kiss each other as you go around. Should stop being lazy. This is a good check, I find, if you're off in your drawing. The geometry doesn't line up quite right, and you'll see overlaps. I've got a couple in here. I hope it doesn't cost me too much. But we'll see how it turns out. Okay, I'm laying this out because I'm interested in how the patterns form in between the circles. Okay, you'll notice these little triangles are starting to show up everywhere the two circles kiss. That's what I'm interested in. So where the 5 is concerned, we're interested in our target circle and these little triangles that show up in between them. What we want to determine is where the center point is in those triangles. And again, if I've done a halfway decent job of hitting my lines, we should be able to find that relatively easily just by looking at points that cross. Okay, and just to be prudent, see if we're going to have any problems down the road with our procedure. Okay, we seem to have a pretty good point here. Okay, it's a pretty clear indication of where the middle of this triangle is. And this distance is the radius we need to find our star pattern. And I'm going to take the leap to put this in a marker because I've done this in previous videos and didn't turn out all that well. It's hard to see. So I'll try and get that under control. Make sure you're able to see it. So if we go to the edge of our target circle and begin tracing the arcs across the entire circle, we should start to notice a star pattern form. And what's curious about this one is that while the radius is still longer, so the radius of the point to the circle is still longer than the radius of the circle itself. It's connecting to the circle on the opposite side of what the other method does. I'm just slightly off, close enough for government work. It doesn't look terrible. Yeah, I'm not too disappointed with that at all. So where the other method would draw arcs that would connect here with the circle. So if you went here, you would connect here. And if you went here, you would connect here. This method hits it on from the other side. So it's like a same side method. If you start here, you connect on this side. If you start here, you connect on this side. It works opposite in the geometry, but the math isn't opposite, which is what's confusing me. The ratio of radiuses is roughly, again, roughly, about 1.15, give or take, between the radius of this circle and the radius of this, from the center of the circle to the center of this point. And what's curious about this is if we were to do that on any circle with any of the triangles of the same relative size. So, I mean, we use these little triangles here because we were using little circles. But if we found triangles for a bigger circle, I'm just trying to think if there's one we can do outside. Let's see if this works. This is an experiment, okay? But this bigger circle here, which is only partially formed, has the same center point as this little one. So if we go to the center of a larger circle, and they're going to overlap a little bit, so bear with me because it's going to get messy. And then go on to that circle. That's the best way to do this. That should be it. And go on to that circle. We should be able to repeat the pattern on this guy, in theory. And it falls down a little bit. I've noticed this happening on the larger circles, where we get these gaps. I'm not sure what the difference is there yet. I have to figure that out. And I might be making a bad assumption on the center. Well, no, because I might be making a bad assumption on where the center point is for these circles. But the theory is, as you can see, the larger one's not quite getting there. I've got these gaps. I'll get 1, 2, 3 that line up perfectly, and then these two go. But on the smaller circles, it's bang on. And I don't know if that's a matter of the ratio, of just the fact that it's smaller, so precision doesn't need to be as tight, or if there actually legitimately is a difference in where the center point is for these, but there shouldn't be, to my knowledge. I'll have to test it to be 100% certain. But yeah, this should be scalable that way, that as your circles expand, this point must shift. Yeah, that requires more research, and I'll get back to you on that one. But at least you can see for this short one, for the little one, this point corresponds to the center to give you your arc length, or your radius length, sorry. And then you can easily do your 5-pointed diagram. It's really rather remarkable, and it makes sense because when you look at some of the 3-circle constructions for the pentagon, there is this offset. There is an offset in the way the circles are drawn. You would draw two beside each other, get your Vesica Pisces, and use that Vesica Pisces to draw a third circle, which would then give you the point for your fourth. And that fourth circle is offset by this difference, or something close to this difference. So this does make sense that it's here, although I've never seen it inside the seed before, which caught me off guard. Let's put it that way. When I found it there. So yeah, I'm I'm continuing to understand what the relation is between this star and the other method that I showed you, so that I can understand how these two lines relate. Because I mean, they end up on the same points of the circle. They have to relate somehow. I just can't mathematically find it yet. So that's still a work in progress. But I thought it was interesting, and I'm happy to point out this little discovery that you can use it to find a star and hide it into other things. All right, that's it for this one. I'll talk to you soon.